Welcome to solverfy, the place where learning becomes simple. If you're struggling with homework, assignment, or doubt in subjects, don't worry, you are in the right place.
Okay, so for this problem, let's use an example. Let's say I'm going to draw a graph here where we have the concentration of A versus time. And this is going to be the reaction of, let's say, A to B. And so we'll say at 1 mole, 0 mole, 0 seconds, and let's say 10 seconds. Just separate that out. So our graph here, let's say, looks something like this. So as we go from a concentration of 1 to a concentration of 0, you can see that there's going to be a decrease in A over a time period from 0 seconds to 10 seconds. So if we're going to be talking about average rate, what we're really talking about is the change in concentration between T2 and T1. So in this case, I guess if we're looking at our overall rate expression, right? So rate is going to be equal to negative 1 over A times the change in concentration of A over the change in time. So if we're talking about the average rate, what we're going to be talking about is the overall change in a given time. So let's say we're going from 0 seconds to 10 seconds. So this will be the change in concentration of A at time 2 minus the change in concentration of A at time 1 over T2 minus T1, which in this example, we can say at T2, which is 10 seconds, it has a concentration, of 0, and at time 1, which is 0 seconds, it's going to have a concentration of 1. And this is going to be 10 seconds minus 0 seconds. And this is going to be, in this case, 0.1. Now, when we're talking about an instantaneous rate, I'm just going to call this INST, what we're actually talking about, instead of taking a rate of, let's say, over a period of time, so for example, from 0 seconds to 10 seconds, the way that you're going to do this, let's say we'd say 5 seconds, this is the concentration of A at 5 seconds. Now, instead of taking a average over both of these time periods, you want to take the tangent at this time, and now you want to find the slope of this tangent. So you can still do the same idea where you have A of T2 minus the concentration of A at T1 over T2 minus T1, but now your times are going to be essentially arbitrarily chosen based on how you draw your tangent line. So let's say your concentration of A, we'll just look at where it intersects each of these axes. So for time, we're going to go from about 7.5 seconds for T2 to about 0 seconds. And in that same instance, we're going to go from, a concentration of 0 to a concentration of about 0.75. Right, so now if we take this equation, so we would do negative 0.75 divided by 7.5, we would get a similar concentration of 0.1. Now, in this case, they just happen to be the same, but in general, these rates don't necessarily need to be the same. But these would be how you would find the average rate of the reaction as well as the instantaneous rate of the reaction.